I'm do it.
Are you recording?
Hello everyone. October 19th. Alright. Flatten nested list iterator. You're given a nested list of integers. Each element is either an integer or a list whose elements may also be integers. Oh, I remember this one. Implement an iterator to flatten it. Implement this class. Initializes the iterator with the nested list. In next returns the next integer. Has next return true if there are still integers, false otherwise. Oh. All right. What do you think? The nested integer has this, holds a single, hold a second. Oh, it'll be tough to implement inside though. It's okay. We'll just deal with it. Return true if holds a single integer. The nested integer rather than a nested. So if we call is integer, right? Return true if this holds a single integer. Get integer. Return the single integer that is, if it holds a single integer. Return null if holds a nested list. Return the nested get list if it holds a nested list. Next. Feels like, maybe we have to do a stack and do the recursion, from a stack perspective. So let's say I have a 1, 1, 2, 1, 1, right? So let's say we have a stack. I don't think this is the right way to do stack. Let's say we have a stack. The first time I call next, right? And I check index. We also have index. Okay, so index point into this. Right, so we push what in? Because I want to handle this thing, right? I want to handle this thing. So I need to in Java, it might not be as easy for me to implement. Maybe there are iterators in Java as well. Like, how do we do this in Java? I think in Python I can just do yield from, right? In Java, I'm not sure. Because if you do index, it's, like maybe you push this index in, and then you do this. and then what? You push the index in. Eventually you find something, and then that's the one you return. And index plus plus. Or you push the entire, man, it would be hard to do. Well, I mean, one way, yeah, we just flatten out the whole thing. That's definitely will work. But we want to make it iterator. How do we do iterator in this? Java has iterator. It does. I feel like that's not the way to go. I think we just have to, do the stack. But I don't like doing stack for recursion. Like, what do I push it in? Well, we need to push the current state, right? The current state. Now you can push the index. But if I push the index, I also need to know which array, right? Which list it is. Otherwise, how do I know where do I continue? Right? Or see, yeah, that's the problem. Because this can be anything, right? I cannot create a uniform stack to hold these things unless I can hold their address. I mean, I push the address of these objects. Is that possible? If I can push the address, right, then I know. Can I do that? Address of object. Is this a possible thing? You can't get an address of object. Yeah, no, that's not how it's doing. But then how? How do I push? Huh. Interesting. I mean, recursion. Okay, so it's not iterator, right? Do they have a yield? Do they have something like yield? Oh, I think they have. There is a yield. No, hold a second. That's not yield. That's just a switch. And keyword yield. Nope, it's for switch. No, generator. That's the one. That's the one you're looking for. Do they have generator? They have it. Generator. What the hell? There is a generator class. I'm not sure if this is the one you want, but maybe. It just says there's no yield, and they say there is a yield. Man, I'm not sure. So I cannot do yield, and I cannot figure out a way how to yeah, you have to do it yourself. Nah, that's not the way to go. What? And the only method I have right now is just to flatten the whole thing. Which I definitely don't want to do. I don't think that's the right way. But if you cannot yield, and I cannot put things into a stack, what else options do I have? Right? What other option do I have? Or you can, I don't know, keep a record. I mean, keep a record. You can keep a record because they are all different shapes. Oh, hold a second. They are not different shapes. They are all nested integers. Ah, they are not different shapes. This is, I mean, we're given a list of nested integers, right? And the nested integers can have, so we're given a list, okay, of nested integers, all right? And the nested integers can be, the nested integers can either be an integer, right, or a list of nested integers. So I can do nested integers. So I can do a stack. We call it a list of nested integers. Okay. All right. Then what? Then what do you push? You take, like this, in this case, right? I'm at index 0 and I have this. I'm pushing, I'd say 0 and the nested integer, the most outside. I push this one into the stack. And then I handle this, right? I go inside. And then I push another 0 and this nested integer, right? Inside. And then, or should I push the next one? Yeah, you should push the next one because you're handling the current, right? You're having the current one you're dealing with, and you push the next one in it, right? You push the next one in it. So after you finish dealing with the current one, you will go back to the previous state and you go to the next one. So yeah, I'll push 1, right? And then I'll do 1, and I handle the current nested integer. And this is good, so I return this, right? I return this. Once I'm done, once I return this, I go to the stack to pop the next one out. Get it, right? I pop it out because that's the next one. And then what? And then I say, is it good, right? Now, so for each element, I check if it's an integer. If it's an integer, we'll return that one. What do you mean by we'll return that one? You need to put the next in it. The current, right? We handle it. We can store it in a variable. Right, we store in a variable. And then every time we do, we pop the stack, right? We pop the stack, handle it. If it's a list, we push into it again. If it's a list, if the current value is a list, then we will push the next one in, and then we handle the current one. Really? Push the next one in and handle the current one? No. If the current is an integer, we return it. Done. If the current is a list, we push the current in. Alright, we'll push the current in. And we get the first one out. That's the one we'll handle. Right, the element. So we get the element out. And then we check. If the element is good, we're done. If it's not good, we get the next element and push those in, right? Until we're done. Okay, we're done. The next time we call the next, we'll pop the top, right? Pop the top of it's going to be an array and an index, right? It's an array and an index. And then we grab the current element and we'll push the next one into the stack, right? And now I have the current element, and it's good. Okay, so what am I saying is maybe we can do it this way. Okay, so we can say list nested integer stack. No. Nested integer, not iterator. Stack new a new array list. And then maybe I can say this dot stack a new array list. Okay, then we have what else? That's actually not right. That should be a tuple. Ugh, a tuple. No. We can do this. Nested integer, two nested integer. The first one is the index, which was always going to be. Can we use nested integer though? That's a good question. I I do not know. I have no clue. I want to know. Can I say nested integer something like that? Oh wait, hold a sec, cannot find the symbol. I can't. You gotta be kidding me. So I cannot do it this way. Oh, new. Huh? I didn't do anything. What the hell? I cannot do that. You know, it's gonna memory out. Wait, what? Wait, hold a second. Oh, it's because of this. I always say true. Okay, so I should say false. But wait, what is the first call? I call this first. Oh. That's fine. We do it this way. Does it work? Yes, so this one does work. And we might do this. Foo dot is integer. There we go. That's what I want to know. True. Okay, so now we can do this. Okay. Then that's the index and the next one. So we also want integer, right? Next value. Has next. So has next. If you call next, we will first check has next. And the check of has next will put the next value into next val. Okay? If it does not have, the next val shall equal to null. Because it says has next returns integer. And then true if it is false. So this will only call if has next is true. So which means I could just say this will always return. Yeah, it says integer, right? I can say this just return this dot next val. Right? Just because it doesn't matter. So this is the main thing. Has next, right? Has next. Well, has next will always push. So I can say this dot stack dot add new nested integer. Two values. Nested integer 0. New, right? And oh, that's not right. That's nested list. It's a list of, oh Jesus. Yes, it should be a list. No. It's a list of nested integers, but inside it could also be a list. So you can get a nested integer Wait, hold on. Let's do one more time. Inside, right? Inside, it's either an integer. So nested integer is either an integer or a list of nested integers. So in that case, so I need to have. Can I have a new class? Stack node. Oh, we can call it node. Public node. Kind of int index list of, because when we push it in, yes, it's only when it's nested integer. That's what we need to push in. So it's gonna be a list of nested integer. Nested. Okay. Then we say this dot index equals index, which we have to do index and list nested integer nested list dot nested equals nested. Okay. Then can we say this is node? I think we can, right? Then we'll do, this is a new node of 0. This is the next index we need to hit, and the nested list. Okay. Then when we do next, we'll pop the stack. And we don't do this, it should be stack. That's what I learned yesterday, you have stack. Okay. Then we can say node equal to, well, if stack this dot stack, I mean we can just call stack. If stack dot is empty, we shall return false, right? You get rid of everything. Okay. Otherwise we can say node current equal to stack dot pop. All right. Then you have your nested, and you have that. Then what? Then you say index, right? Int index equals current. I mean, we can just use that. It depends, right? If the current node, we have index, and if that is a good one. Okay, so a couple things, right? A couple of things. If current dot nested current dot index dot is integer, right? If the current is an integer, then we will say next val equal to current dot nested current dot index dot get integer. That's if the current array type expected. Isn't current is node, right? Oh, shoot, my bad. A list get shoot get. All right, so we get it. We'll get an X val, right? Else, if the current is not, then again, you push it out, you pop it out, and you say if the current is integer, right? Then we need to push the next one in. Then we shall say if current dot index plus 1, that's the next one, is smaller than current dot nested dot size, right? Then we shall say stack dot push. Not add. Push. New node current dot index plus 1 current dot nested. Right, so we push new thing to the stack. If it's equal to, that means the current is all done, then we don't push anything. So that's that. Else is the current is not an integer. If it's not an integer, it's a list, right? It's a list. Then we do the same thing, okay? We have to push this back. I guess we'll have to push this back anyway, right? We'll have to push this back anyway, no matter what. We have to push this back. Because you pop this out, you're checking the current one, so you have to push this back for the next round. And then if that's the case, then we're done. Otherwise, right? Otherwise, but what if we just keep calling .next? Yeah, we'll have to fix that, but later on. Otherwise, the current is not an index, is not an integer, right? Then we'll push that in, and a call has next again, right? We have to push that in, and call has next again on that. Otherwise, we have to, so we get the next val, so that should return true. All right, otherwise, we shall push it in. Push what in? We say stack dot push new node 0 current dot nested dot get current dot index dot get list, and then we return has next. Okay, so we go and then we have next, so we call again. Eventually we'll return true, right? So we'll return true. and then we'll return this. But what if I call next again? Right? We call next again. So every time I call next, right? Every time I call next, I shall do has next, and then and every time we call has next, what's the order? Every time we call next, we just return the value. And then we call next again. We cannot just return the value. So we only call next. We have to get next, right? We have to have a function called get next. So I think we have a private function, integer, call it get next. Okay. And I always say if it's empty, we'll return. Can we return no? Yes. Return next. Now we just return this. Right? We'll return this. Otherwise, we'll return get next. So once we call this, we can say next val will equal to get next, and I'll return next val. Right? Has next. Hold on. If I call get next, I shall say if next val is not equal to no, right? We shall return next val, but also set next val. So I need a right, set next, thank you, to no, and then we return in temp. If it's not, if it is, then we will call get next, right, and return this. Or we shall say, we can say call has next, right? We can call has next, but that's fine. We'll do this, right? Has next. If next val is not equal to no, we always return return true, right? That's actually we can do in one line. Otherwise, then we'll say next val equals to get next, and then we return next val is not equal to no, which can actually be simplified. Say if this is equal to no, we get the next val, right? If it's equal to no, we get the next val, and now we return this. If it's not equal to no, then we just do this. So we can keep calling has next. It won't move forward. Then when we call next, we say if it's not no, right? We call next. If we call next, maybe we can do has next. So what has next? Then we return. Yeah, I think I can just do what has next. No. No. Hold on. Because when I consume the current one, I need to set it to null. Okay? After I consume the current one, I need to set it to null. Which means if next val is equal to null, so I will first call has next. Right? I'll call has next. That's fine. I'll call has next. This will always give me the next one. And then I'll set this to this, and then we'll return temp. Make sense? Oh. Nah, that's fine. Right, always has next. When you call next, you always call has next first. So this one will give me the next value. Right, now so that next value, I consumed it, I set it to null. Right, I set it to null. So if I call has next again, we'll get the next value. And then you keep calling, they'll keep giving you. And then you call next, we'll get it. Then what's the purpose of setting it to null? Right, what's the purpose of setting it to null? Because you set it to null, because of that, you won't just keep having next. Yeah. I think this makes sense. Right? It makes sense. Need to have a give a little check on this. Does it work? Cannot find symbol. Current dot nested, not next. Nested. Okay, this one looks to be good. Oh, that's it. We have 2. Okay, let me try. So 1, 2, 3, 4, 5. 1, 2, 3, 4. That. Oh, I think this one looks good. Give it a shot. Ugh. I was able to do it without error. Dude. What is this? Empty list. Well, it's not supposed to be. That's not supposed to happen. current 0, and this is this. Okay, that don't push. And then dot nested dot get. I guess I have to make one more check, right? So if current dot index is smaller than current dot nested dot size, and oh, I think this is a problem. Dot get integer. Otherwise, it's not an integer. And I need to push this, and it's only if we have something, right? Hold a second. Current dot index is 0. Smaller than that. We say the nested, yeah, we don't have. So again, if current dot index is smaller current dot nested dot size, only when that is true, we push. No, that's not even index. That is 0. Or we can just say, this is basically just current dot nested dot is empty. Right? If it's not empty, then we do it. Cannot find. We always say nested. Okay, try this. All right. Pretty sure there's a better way. 341. Recursion using stack. So what was the previous method? 43. Jesus. I spent so much time trying so hard to actually do the to do it correctly, and you see my solution was just to unflatten it. That was kind of disheartening. Did I do the unflatten for every single time? No, this one is an unflatten. Prepare. From right to left. You put stack while this, if this, return true. Otherwise, you prepare Oh, oh my. Oh my, this is good. How do you even think about things like this? That was good, right? That was pretty good. So, what this means is you have a list of nested integer. The stack just means the earliest one need to get processed. The first, right? So you push this in from right to left. Yeah, I can see you push this from right to left. Okay. So if I have 1, 1, 2, and a 1, 1, I push it in. It will be 1, 1. This one, let's go 1, 2. 1, 2, 2, 1, 1. This is my stack. Okay. So now every time we go, we check this. Right? We check this. If this is a if this is an integer, then we're already done. If it's not an integer, we grab this and then we do the same thing. So let's say this is a 2. Okay, this is 2. So we grab this stack, right? We pop this one out, and then we go from 1, 2. So 2 will be the first one gets out, then 1, then 2, then 1 and 2. Oh, that was so much better. That was so much better. Dear me. Alright, so we don't need this. We don't need this. Right? We don't need yeah, this is a better, much better recursion. We still need a stack, but this is just going to be nested integer. Right? Oh, what is this gonna be? It can be an integer, or can be a list. Yeah, it just nested integer. That's the stack. Next value will be hold in the stack. And we have a private void expand. Expand what? Expand a list nested integer. Nested. Okay. Then just say for int I equal to nested dot size minus 1 I equal to 0 I minus minus stack dot push nested I. Not nested I dot get I. Right? So that is our expand. And then has next. Well, has next will be if stack dot is empty, if stack is not empty, and stack dot get stack dot size minus 1 dot is integer, return true. Otherwise we will pop it. Right, we'll pop it. Then we say nested tail equal to stack dot pop. Hold a second. If stack dot is empty, return false. Right? Otherwise, we do that. We return true. So this one will pop it, and then we say expand tail. That's not true. That shall be. This is that. Nested. Just say list nested integer L equal to nested dot get. Oh, hold a second. No. We can still do list expand dot get list. Right? We call tail dot get list. We don't even need tail. We do that. And the return has next. And when we do this, we always call has next, right? And then once we call has next, we will return well, we can say if has next, we return stack dot pop dot get integer. Otherwise, we'll return null. Okay, let's try this one. This one work? Oh, my bad. It's not push. This is expand. Yep. Right? Yeah, it's much better. Same runtime, but implementation-wise, smart. Okay. Let's put this one in. Yeah, this is the right way to do it. Make flat list. Nah, that's not. That's just lazy. Stack is the way. Remove first. Yeah, that's that method, right? Two stack. Oh, two stack. Pushing every item of a sublist onto the stack. An index pointer with each sublist that keeps track of how far along the sublist we are. Wait. Index stack. Integer 9. An item stack, an index stack. Huh. So we start with item stack. Index stack is 1 because we are handling pushing this in, right? And then we should point to 2. and we're handling 4. Okay, which is good. So we pop it. This comes up. Is that 3? Pop it. Come back. Gone. This. Oh. This one goes up. 0 up. This one become 1. Yes. This is 0. Oh. 2 stacks. Wait, what's this remove? That's a deck. I think first is on the right hand side, right? Two stacks and a stack of iterators. A stack of list iterators. Add first. The list iterator. Turn this into an iterator. Set peaked. If this is not empty, remove peak first. If the iterator has at the top doesn't have a next, remove that and then going on. Otherwise, next will be peak first dot next. If the next is an integer, set the peak. If the next is not an integer, we'll add. We'll add next dot get list dot list. We'll get a next list iterator. Oh, this is like what I have here. We set a next val, but we're doing everything by hand. And then yeah, we get a next, we set a next, but once we consume it, we set it back to null. And then if it doesn't have next, the generator. If it's integer, we yield. Else yield from. Yes. And then next. Oh, it's the same. Peaked. Next integer. Otherwise, auto peaked equal to next. Yeah, we save that value into peaked. I think we can try. I'm not sure about this, the 2 stacks. I guess we can try 2 stacks. Now, this is one of those problems. I'll put it here. Definitely worth another shot. Okay, but that'll be it for today on this one. Do you want to keep doing this? Yeah, I think we have. Let's see if we can do it in 10 minutes. Given 2 values, return a deep merged value. Deep merged, according to these rules, if the 2 values are objects, returning object should have all the keys that exist on either. If a key belongs to both, deep merged 2 associate values. What if the 2 are values? Otherwise, add the key value pair to the resulting. If the 2 values are arrays, the resulting array should be the same length as the longer array. Apply the same logic as you would with objects, but treat the indices as keys. Otherwise, the resulting value is object 2. So in this case, the value of A changed to 2 because if both have the same key and their value is not an array or object, then we change this to 2. And what about this? Result 0 is because object this and this have different types. So if they have different types, we follow this. Result 2 does not exist because object 2, yeah, that makes sense. So A is fine. B is 2, that's an object. So we need to merge these 2 objects, okay? Then DE, then C, then we need to merge this. This is 1, 2, 3, 1, 2, 3. So when we merge them, if the 2 arrays, the resulting array should be the length as the longer one. All the key that exist on either. If a key belongs to both, deep merge the 2 associate values. Okay, so they're both of length 3. So we merge the first one, we take this. We merge the second one, should take 2, 7, right? Should take 2, 7, 2. But 6 belongs to the second object. How about this? We'll take the second object. Merge the values, overwrite. Only if they are not arrays object. Yeah, it's not hard, but I think the rules can be a little bit confusing. We'll see if we can get the rules right. All right, so is obj. Obj is not equal to no, and type of obj is equal to object. Okay, so if both are not object, so if not is object, so this is not object, and if neither is object, return obj2, right? If neither is object, return obj2. And if array dot is array obj1 not equal to array dot is array obj2. So one is an array and the other is not an array. Always return obj2 because they're not matching. Now they're matching, right? Now they're matching. So now they're matching, we want the maximum of their keys, right? I want the maximum of their keys. How do I do that? So I go with the second one, okay? So I can do const key set. Right, key set, we can do new set object.keys object1, right? And then we say for let key of object.keys object2. Const res, right? And then res key shall equal to deep merge object1 key object2 key. What about array? Yeah, I think array they have to be considered differently. They have to be considered differently, right? So we shall say if array dot is array object1 const res shall equal to an array, and now we return res. We handle it, return res. Otherwise we do this, right? And then what? So we go through all object 2. Now eventually we'll say, or every time we do it, we shall remove. So JavaScript set remove delete. Then it doesn't matter, we just delete. Key set delete key, right? At the end for let key of key set res key equal to deep merge. No more deep merge, because these are exist in object 1 but does not exist in object 2. So I'll just do that, right? And I'll return res. So here's the same thing, right? Here's the same thing. Actually, it's not really the same thing. Yeah, it's not really the same thing. These are fine. This is actually not fine. This, I think, but we still have to check, right? Okay, so we say 2, right? And then we say res is this. That's okay. For int I equal to 0, int let I smaller than obj2.length I plus plus. We do res I equal to deep merge obj1i, obj2i. Right? Once we handle everything, if there is additional, right, for let I equal to obj2.length, I smaller than obj1.length, I plus plus. Res I equal to obj1 I. Then I return res. Okay, give this a shot. Looks promising. Ugh. Cannot convert undefined. Oh no. How will we get undefined or no? One of them is no. One of them is no. It's not handled here. Oh shoot, I think it should be equal to no. No. Equal to no is not object, it's object. I think I should add one more. Obj1 is equal to no, not equal to obj2. Or actually just says if one is no or the other is not no, is undefined. Undefined. If one of them is undefined, or this is undefined, or obj1 is equal to no, or obj2 is equal to no. But no is handled here. So if I say obj is not equal to undefined, and if it is undefined, then this will be false. Yeah, hold on. Let me try this one here. Put undefined in. It's still what? I thought it was enough. Because deep merge, one of them is undefined, right? Obj1 is undefined, right? Because G doesn't have, so it's undefined. So obj1 is undefined, the other is, so the other will be false. And the other is yeah, the other is undefined. So shouldn't we already return? Yeah, I don't understand. Right? It's, wait, hold on. It's here. C and D. C and D. So once I go D and the other one is undefined, How is that possible? obj1 is undefined. And then we have, this is weird. We start with ABC, with ABD, and then B, and then we have C and D. Yeah, C and D. So it's undefined. Object 1 is undefined. Undefined, that's false. Alright? So this one will be true. Oh, this is true. And this is false. So one is not an object, and the other is an object. Ugh. Okay, both are not objects. Or is obj obj1 not equal to is obj2. In fact, we can just add this one as well. All of them, right, will return. That's it. Yep. There we go. Yeah, we have a little bit, so it's both. Yeah, this is, so the situation where we return obj2 is obj1 and obj2 are neither objects, right? obj1 and obj2, one of is not object. obj1 and obj2 are not both arrays or both objects. And one of obj1 and obj2 is array and the other is object. So these are the cases, right? Otherwise we just do this. Okay. Yeah, it's not too bad. Is that like 10 minutes? A little bit more than 10 minutes, but it's okay. It's fine. Oh, I guess. Oh, this is actually pretty good. You set to object 1. If keying res. Oh, this one's good. This is good. Better implementation from this doesn't change. Now we don't have to check this. We set res equal to object 1 for let key in object 2. if key in object 1, right? Then we say res key will equal to deep merge. Else means it's only object 2. Okay. Oh, that was so easy. That was so easy. Yeah. Oh, so good. Very smart. Faster as well. Okay.